Good morning to all. In last time we just see how the linear search is going to be work, right, using array function or you with the help of array. And now today we are going to be discuss how binary search is work. So to implement our assignment, that is ternary search, we must to understand how the linear search work, how binary search work, and then we are going to implement a ternary search. So let's start with the binary search. So first of all I'll execute the code and then I'll explain the logic. So if we execute this program, that is implemented as binary search, so what exactly my output is, first of all is going to be ask you how many number of record you want in that array. So if I say I want 8 number of element in this array, so I'll say 8, and now I want to give the random data set. I can say 8, 45, 21, 2, then 1, then 98, then you can say -1, right, and 6. So if I say, now you can see over here the array element is an unsorted order, so whatever the data we inserted, that is my unsorted order. As we know that binary search is work only on the sorted data, so first of all we need to apply the inbuilt sort or sorting function to sort our data. So once I sort the data, my data is going to be arranged in ascending order. So you can say -1, 1, 2, 6, 8, 21, 45, 98. So accordingly the 8 element whatever we inserted, the data is going to be sort. Now what is this is the data we want to search, that whether it is present or not, that we want to indicate. So if I say I want to search this 8 value, right, so if I say I want to search 8, so it says 8 is found at index 0, so you can say index is 0, 1, 2, 3 and 4. That means what, 8 is available in an array at index number 4 position, right. So if the data is available, is going to be show that the data is available at particular index. But what happen if the data is not present in this case? So if I run the code again, now if I say I want a 6 data in this case, 9, 1, -2, 5, 0, 6, 6 data is there, right. So after sorting data, -2, 0, 1, 5, 6 and 9. So if I say I want to search 10, so element is not present in array. That means what, if the data is not available in this array, the message is going to be displayed that the element is not present. Now let's understand how this program is implemented. So first of all we are going to create an empty array, right. So this is a list we created over here, right. So this line is used to create an empty array, or you can say list, right. Then we're asking how many number of record you want to save in this array. So this particular line is used to ask from user how many number of record you want to save in this array, right. So once the record is the data is entered, right, in this case the 8 is by the value, so 8 is going to save in this variable number num. Then one for loop is applied, right, that is used to accept the data from a user, and that data we need to add inside a array. So to add an array we use .append command. So list1.append, so what is the number you entered from a user, that number is going to be saved inside our list. Then we need to print our list. So here the first line is my unsorted order data is going to be printed. Now as we know that binary search is implemented only on the sorted data, that's the reason first of all we need to sort our data. So inbuilt sort function we are use over here. So here we are applying a sorting function. So this line is used to implement our sort. So this is the inbuilt sort function which is sort your data in ascending order, and once we sort the data we are just saying print my sorted data. So array element after the sorting list, so list 1 is, so you can see over here that is the output of that particular sorting mechanism is displayed over here. Then we are accepting a data, so you can say please enter a key to be search in array. So we can modify our message in this case, instead of please enter the string, so please enter a key to be searched in array. Then that key is going to be saved over here. Then we apply a binary search, we return a binary search function where the key and list1, that means the data to be searched and the array is going to be passed as an argument to this particular function. So let's see the what the we return in the function. So a def is a keyword is required to return a binary function. So binary search is my name of my function, item, that is a formal variable, which is key is whatever we pass, that is going to be saved in variable item, and the list one is going to be saved inside item list. So then first the array is always started with the position 0, that's why we is indicating first is my index position is always started to 0th position, as we don't know the last position of array. That's the reason first of all what we can do, first of all we find out the total length of item list, right? So length item list minus 1, because if I say item list is having 8 elements, so it's always 8 element, but indices of the 8 is what, is just 7. So you can see over here 0 is my first index, 1 2 3 4 5 6 and then 7. That means if I have 8 element, my last indexing position is 7. That's the reason we need to, what we need, last is equals to item list minus 1. So length is going to be calculated, minus 1 is used for your last position of your array, and found is in just variable we are going to be used over here. So when the value of found is going to be changed, that means my data is available, right? So as we know that in binary search we need to find out a mid element first. So mid element is going to be identified by mid equal to first plus last double divide by 2, because in Python double divide is used for your integer kind of value. So if you use a single digit division operator over here, then your output is not going to display appropriately. That's the reason we use the double equal to operator. Then if the item, that means whatever the first list is available, so you can say list is going to be divided into half. So if item list of mid, is it equal to item, so whatever the element we want to search, if it is equal, right, then we'll just say found is equal to mid. Mid is nothing but a position where the element is found, and then we'll break from the loop. So once we break, right, so we break from this loop and then return a found. So whenever the element is available, we'll directly return to this particular flag, return back to your function called line. Then this value of mid is going to be saved in variable flag. Then we are comparing, if my value of flag is greater than 0, then we can say my element is found at particular index, right, where the index is stored in variable mid. When it return, it's going to be saved inside variable flag, right? That's the reason it's showing me the output is 8 is found at index 4. Now let's understand, if the data is not available, then what happen. So if the data is not available, in that case what happen, again we need to compare whether my element is less than or greater than with that mid position. So now here we are saying that check whether item is less than a mid value. If it is less than mid value, that time what we can do, we are just going to change the value of last. If it is less than, that means if the data is available on the left hand side of my array, then we change the value or the index position of last variable. So that going to be changed with the help of last is equals to mid minus 1. So whenever we return last is equals to mid minus 1, the data is going to, the variable is pointing to the previous position of mid. Then again we need to implement the same thing. So that's the reason we apply the while loop over here. So up to what point we need to perform the searching, when first is less than equal to last. That means whenever the indexing position is not equal, right, up to that point we are going to be continue this search. And so here and condition is written, and not found. So not is an inbuilt keyword, right, that is used for the identification as a boolean operator, and not found, right. Not means what, it is a not operator is there, so 0 is going to be converted to 1. So not found is true, then only we are going to implement this method continuously, right. So in this case, if my data is not available, is showing me the output, my element is not present in array. Agree with this? And once my data is found, then we'll say return found. So if I want to cross check it, what is the value of my flag, right, so we can see over here, we can just write down a simple print command, right, and value of flag we can just cross check with this. So I can just say value of flag is equals to, and just we print the value of flag over here. Now if I run this program again, right, so if I want to say I want 4 values in this array, 4 8 2 and 1 sorted is there, and I want to search suppose a 9. So you can say the value of flag is 0. So value of flag is not going to be changed. That's the reason element is not present in my array. If I again run the same program over here, and again I say if I want to say 4 data, 5, 4, 9 and 1, and now I want to search suppose 1, then you can say value of flag is 0. Okay, I think some mistake is over here. Value of flag is not changing in this time. Okay, let's execute it again. 4, 1, 2, 5, 9. Okay, see, 2 is available at index 1. Okay, what exactly happened here? Value is available is 0, but 0 is not greater than, so I can say is it equal, right? So if I say is not equal to 0, if I say greater than equal to 0, yeah, then my code is going to be work appropriately. Now if I run this program again, I'll say 4, 5, 9, 8 and 1. See, value of flag is 0 and 1 is found at index 0, right? That means what? Equal to condition is not returned. That's the reason in first example the value is present but it's not reflecting. You can see over here the 1 is present in the array, but its element is not present because equal to is not written over here. So for 0th place we need to apply the equal to operator. So if the equal to, that means if data is available, we can search for the last data also. If I run the again program, I want 5 data, 9, 4, 6, 2 and 1. So you can say 9 I want to search, you can say 9 is found at index 4, right? And you can say value of flag is 0. This way the binary search work, right? So you implement a binary search first, and then we'll going to discuss about your actual assignment that is known as ternary search. Okay.